Okay, I think we're live.
Yay, awesome.
Well, hello everyone. So thank you all for being here. I'm with Valentina, and I am Andrea. So we're having this real world on world assets workshop, and so hope you like it. Valentina, you want to intro yourself before I start with a brief presentation? No. Okay.
I had an echo. Sorry, that was a little bit weird. Are you hearing the echo to you?
Yeah, it's hearing good. I mentioned if you want to get like a brief intro about yourself before I start with the presentation. Okay, you're probably not hearing me. Anyway, I'm gonna start.
I can hear you. Sorry, it's just that there's an echo, like I said before. So I'm just gonna let you say what you gotta say, and then I'll say what I gotta say because I don't know if other people can also hear it.
Okay, then I'll go start with the presentation. So, yeah. So first of all, a brief intro about myself. I'm senior developer relation engineer at Avalanche. Avalanche is the company behind the development of Avalanche, and my work here is basically trying to make developers' life easier. So any question, please drop it in the chat. We will be able to solve that at the end. And so the first part of this presentation is going to be about why building real world assets and why doing that on Avalanche. And the second part, Valentin is going to take over to give a workshop on how to integrate Chainlink into this development of real world assets. So the first is, what is a real world asset and why we care about this? So a real world asset is basically a tangible or intangible asset that exists in the real world, like in the physical world, but we represent this asset on a blockchain, or we do it on chain. So we have some benefits around that. So this could be anything that you can think that is like it's existing in the real world, such as stocks, bonds, housing, like any real estate, any product that you can think that is manufactured. Even money can be a real world asset, and you can tokenize that in on chain. So anything that you can think that exists in the real world can have a representation on chain. But what are the benefits of doing this? Well, basically, having a digital representation of this asset will give you first enhanced liquidity. So this will increase the liquidity. You will be able to even because it's digital, you can you can have a fraction of this asset, and having the ability of, for instance, increasing the accessibility of this asset by only purchasing a piece of this asset instead of the entire asset. You will have also a market that is more liquid in the sense that you have access to different markets globally, and not just limited to certain region or certain country, let's say. Having this in blockchain will also give you the transparency record of ownership, transactions, everything that happened with this asset. You will have the historic version of this. So basically, you will have the ability of see what's happening with that in historical record. You will also increase the efficiency because you will be blockchain make you settlements like really fast instead of, or comparing with the real world process right now. You will have you will lower the cost of transacting, and you will also increase the speed of doing this process. And also you will be, because you having this on chain, you will have access to the whole world that is already developed, or DeFi of different application and infrastructure that is already there. So you will be able to also benefit from the automation with smart contracts. So basically, having an asset on chain will give you the benefits of having anything digital, but also with the security of being on a blockchain. So having said this, or having explained the importance of the real world assets on chain, the first example that we can think of, I mentioned we can have money on chain. So we have the US dollar. We have some representations of the US dollar as stable coins. And these stable coins, I mean, anyone can launch a token, right? So why these specific tokens are worth or cost $1? So the thing about these that anyone can build a token, it's just like, I can say this worth $1, but if the market doesn't think that this is worth $1 because it's not completely backed, or there is no mechanism that ensures that this is actually worth $1, then nothing's gonna make sense. So you need to have a way to ensure that this relation one-to-one stays there. So how some of these stable coins work is that because we're working with the real world, there is some way to mint these assets. So for instance, for $1 that it's in a bank account, a company will mint one of these tokens. And these, of course, can have different questions or raise different issues about like centralization of this part. But there are different ways. At least this will be backed, right? And there are other ways to back these assets and make sure that they are worth $1. So for instance, what DAI does is that they have MakerDAO that with an on-chain mechanism and a bag of different on-chain assets, they will make like a balancing mechanism, on-chain mechanism that will also always ensure that a proportion of assets is always worth the amount of current on-chain circulation of these DAI. So that way you will have a way to ensure that the bag that is backing all these assets is also always worth $1 for each of the coins that are minted. So this is an on-chain mechanism. The other one is an off-chain mechanism of backing. But at the end, if we think of different mechanisms on different assets, on the different parts of these real world assets on chain are the asset, that is the asset you are representing that lives in the real world. Then you have the collateral or the backing mechanism to ensure that this is actually worth what you say it worth. And the final thing is the representation of that first asset. So that is basically how you want to structure the asset. But actually, when we are trying to bring assets on chain, we have some challenges. And these challenges come from the compliance part, in the sense that you need some jurisdiction, or you need those that work with the real part of the world to recognize this tokenized asset for legal purposes. You need to enforce ownership, and you need the compliance part to also be able to solve these disputes and uncertainty on these use cases. So you basically need their on-chain asset to have some kind of recognition in the real world, because at the end, it doesn't matter if you say I have a house, I have token of a house, if there is no mechanism or legal entity that can say like, yeah, this is your house because you have the token, or this is your ownership, this is recognized in the real world, then it won't make sense. The other thing that we have is technology. If you're bringing the whole activity, imagine having a lot of real world assets. We know how we can get benefits of having these assets on chain. Well, if we bring those assets on chain and all the transactions that happen right now in the world, there's a lot of volume of transactions. So we need a technology, or we need an infrastructure that can support that specific amount of load. And also, one thing that we need is to be interoperable with the different protocols out there, and also be interoperable with the real world. Why? Because if we don't have this interoperability with the real world, and we need to get this information from the real world, we need to get pricing. How do I know if this house worth a certain amount of money? How do I know if this house actually exists? What is backing this token or this representation of something? Is there this something actually in the real world? So that is something that we will be working with Avalanche and Chainlink, so you can get, for instance, the pricing, or you can get real world data into the blockchain, so you can start working with that. And that is what we will be doing in the second part of this workshop that Valentin is going to show us. But so now that we have explained some of the challenges that the real world asset face, let's talk about like why Avalanche, right? Why Avalanche is a suitable place to develop these kind of assets. So for those that are not familiar with, Avalanche is not just one blockchain, but it's more like a network of networks, where you can launch applications on top of existing blockchains, or you can build your own infrastructure that meet certain requirements, such as compliance requirements, even know your validator, know your customer requirements, so you can actually bring these in a compliance way. And one important thing as well when we are talking of interacting with the real world is that Avalanche is the fastest platform in the blockchain industry measured by time to finality. And what time to finality means is whenever a transaction is set on stone. So to make this a little bit clearer, so imagine you are doing a transaction on chain, you are transferring one asset, and so some event happened, and then you need the real world to actually deliver the product or whatever, right? So event A happened, then you transfer the asset. But what happened if the transaction that you were thinking that already happened, such as a payment on chain or a transfer of ownership of the token, gets reverted? Well, what happened with that transfer asset that was that asset was already delivered or transferred to someone else? What will happen in that case? So if we are working with real world assets and we are interacting with anything outside from the blockchain of destination, of source of the event or whatever, where the token is based, you will need to wait for the finality of this transaction to actually deliver the product or to execute some other action in the real world. And this not only happens in the real world, this also happens when interacting with cross-chain applications, so with another chain or another environment that is outside the blockchain. So that is why the finality is really important in these use cases. And how we achieve this is via a consensus protocol. I won't get super deep into this, but it basically allows us to have instant finality. We can scale to thousands of validators, and it's a secure, it's a really secure algorithm, since it can be parameterized to achieve up to 80% of the security threshold versus the 51% attack that most of the blockchain have. This can ensure 80% of security warranties. And it's also eco-friendly since it's used in combination with the Avalanche consensus. It uses the proof of stake. So basically, this is the engine that is powering all blockchains on Avalanche. But the other thing is the architecture and how we can scale to accommodate that amount of transactions that require to tokenize all the world assets. So basically, and for you to have an idea where we will be working today, is Avalanche was born with three main chains, or three primary chains. This is the X chain. This is just to create assets in a native way without having smart contracts. This P chain allows for cross-chain communication within Avalanche and handles all the validation information. This is where staking happens. This is where anything related with custom chains happen. And the third one is the contract chain. This is the EVM chain. This is where we will be deploying our tutorial today. And this is basically just compatible with all Ethereum or EVM tooling out there. So you have smart contracts, you have NFTs, you have a lot of dApps in here. And that is a nice place to start if you want to launch your own dApp. But also we have what we call Avalanche Layer 1s, or you can launch your own infrastructure. And this is important for the compliance part. And when you want to fit the specific needs of all the use cases that can be out there in the world, right? We're talking about real world assets. We're talking about different needs on the whole world. And the best thing to do or optimize for these use cases is to basically build the best infrastructure for these specific use cases and then connect all of them in an interoperable manner within one single ecosystem. So why would you want to have this chain deployment while you can build just one on top of one existing chain? Well, the first is you can have fee isolation. So if you have a lot of transactions in one chain and you want to have predictability on your own application, if you develop where everyone else is developing, you probably will have or experience gas peaks. You won't have predictability. You will face network saturation. It doesn't matter how performant this chain is. If you are planning to give everything or put every activity on the world in that chain, that is going to get some point of saturation at any point. So imagine if you are building on top of this, it's like saying I'm trying to buy a ticket for the cinema, but I get increasing in cost because Taylor Swift is having a concert. So you won't have this isolation of performance, and probably you're gonna face different issues when you're developing on top of where everyone is developing. So you can decide to have your own environment, you can decide to have your isolated performance, and have predictability on the cost, have a more stable experience for your users, and at the end that will translate in a better experience and more at least a more performant application. Another thing is that you can also decide on what the gas fee is going to be. So imagine you pay the transaction fee in US dollar, or transact in real world coins, right? So you can start thinking about having customized fees. You can think about having customized block space, whatever you need. I'm going to go a little bit quicker, but the idea about customization is that we know that all use cases out there in the world need to comply with different requirements, need to be, they all are different. So the idea of customization is being able to, via these custom layer ones, is to be able to accommodate those specific needs in the best way possible. So what you can customize on Avalanche is basically everything on the stack. You can customize from the execution layer. Avalanche is virtual machine agnostic, so you can have EVMs, you can have move VMs, WASM VMs, even build your own VMs with Hyper SDK. It's an SDK to build virtual machines. And you can also build on top of any language that you like. You can build on any application layer as well. So basically, you can go on any layer of the stack. And so what this benefits at the use case level is that you can say, as I say, your own gas token. You can have access control. For instance, if you want your application to have this KYC process or KYC regulation, you can make that happen because you are restricting, or you can enable some kind of allow list in these blockchains. It doesn't mean that you need to, but you can do it. You can also make your own tokenomics to work for your use case instead of working the other way around, that your use case work for other tokenomics, but actually having your own infrastructure. So you can say like, okay, let's imagine I want to build an application for real world assets on Europe or in some specific legislation. You can decide that it can be as decentralized as you want, as long as the validators are in certain specific legislation. So this way you will have one blockchain, your own rules that follow a specific needs. So from the validation to who can deploy smart contracts. Imagine you are building an institutional subnet, and for some reason someone comes in and develop a PFP NFT project. You probably don't want that. You don't want that space or that own resources that you are putting together to be occupied in any other way that is not intended for your use case. So you can decide, like, I want these to fit some specific needs. I want these to set on these specific rules. So you can do that in your own layer one as well with users. And the other thing, this is about the permissionless permissioning that you can decide, or you can even build a permissionless network as well. So it's basically do the best infrastructure for the use case that you are looking for. You can go on the C chain that is completely permissionless. Anyone can join, and this is what we're doing today. Or you can build a specific, even restricting subnets or your own chain. So it's basically as custom as you want or you need. So that is what Avalanche is. That is why it is allowing, or what it is bringing to the ecosystem of blockchains. And this is why a lot of of institutions are already tokenizing different assets on chain, such as private markets. Citi is doing this. We also have another a proof of concept of Citi is developing an FX solution on Avalanche, and also we have JP Morgan as well with Onyx. So we have really big institutions, as you can see, and we have working with the Monetary Authority of Singapore as well. We have a lot of institutions working on top of Avalanche because we can accommodate these specific needs that these use cases have. So basically that's it. There's a lot more to that you can learn on why Avalanche fits in this specific use case. And you can also check this out in the Avalanche Academy. We have whole courses on how you can customize these subnets. The link is down here. You can get in academy.avax.network. Just check that out. We have different courses. We have Avalanche fundamentals. We have customize your virtual machines. We have anything that you want. Build cross-chain application. It's really exciting actually to get in. It's completely free. And each time you finish one course, you will get earn some certificates that you can put in your LinkedIn, just show to your friends, whatever you liked. So yeah, Avalanche is a great place to start building this kind of assets, especially because we are working as well with Chainlink, and we have integration of these services, so you can read off-chain data or real-world data into the blockchain. So basically, that's Avalanche. I also leave this QR code so you can get some of the developer resources, and if you and then that's basically a high overview of Avalanche. So now I pass it to you, Valentina, so you can go with the workshop part. And thank you so much, everyone.
Yeah, thank you so much. Just wanted to make sure I wasn't on mute. Can everyone hear me well?
Perfect.
All right. Well, thank you, Andrea. That was very great. I love Avalanche and I love everything all the innovation that's happening on there, and especially as it applies to allowing for us to use tokenization on chain. So let's go ahead and hop into it. So first and foremost, thank you all for joining us today in our discussion or masterclass rather on tokenizing real world assets using Chainlink functions on Avalanche. And I am one of your co-hostesses. I am Valentina, but you can call me V. And I'm a developer relations engineer at Chainlink Labs, and I have extensive experience in various blockchain development and development environments in general, from front end to back end and everything in between. But today I'm honored to have the opportunity to discuss with you some of the things that I've learned as a blockchain engineer with Chainlink. So Chainlink has done a phenomenal job at delivering solutions, and we're going to discuss one of my favorite ones, which is functions. And there's also going to be a very nice element to this where we're going to get into some live coding as well. So I'm looking forward to working together to tokenize some property. So our property that we're going to be discussing is going to be tokenized on a blockchain. It's going to be a tokenized representation of your asset. And it's going to allow for you to take advantage of the best of both worlds. So you're going to have some of that sort of transparency that you have with the blockchain elements and the programmability aspect. And I strongly believe that tokenization is the future of finance, and it's going to allow for us to have a lot of very unique use cases that we can build onto, which is why we're going to spend the next 45 minutes or so discussing one of my favorite Chainlink products, its functions, once again, to bring these real world assets on chain. So feel free to take this masterclass and remix it and work it into your own and use it for your own use case. And after this workshop, you should theoretically be able to produce and reproduce what we've built today to make other sorts of things tokenized, like stocks or like Tesla or GameStop or whatever it might be, or bonds. There's endless opportunities to tokenize assets that you may have. So let's start off with going over the structure, what we're going to be discussing. We're going to look at functions and under the hood and how they operate. And then we're going to look at how we implement that operation. And then we're going to review the code together. So in order to follow along with me, please do look at that link that was just posted in the chat. It's also in the description. It's Chateau Voyage or chateau.voyage. And that's going to give you what you need to know in terms of where to go for finding, my cat, for finding that necessary pieces of information. So before we continue, though, I do want to mention that there are some assumptions that we're going to be making for today's demonstration. Namely, we're going to have to assume that there is a broker that exists and that this broker is an external actor who is well vetted and able to issue these tokens. But before we get into what that means, let's first off look into what issuance means. Issuance is basically just looking at real world assets and being able to offer those assets and saying that this person actually owns its assets. So real world assets exist off chain, which means that we can't really cryptographically verify ownership of them. So we have to make the assumption that there's a reliable third party that's the issuer of these tokens. And we have to do so in a manner that reflects actual ownership of that asset. So, for example, you could say that you own the White House, but you even mint a token that says that you own the White House. But unfortunately, you do not own the White House. So that actually be a pretty illegitimate way of declaring ownership of a property. So since anyone can mint anything on a blockchain, the weakest link comes down to the reliability or ultimately the trustworthiness of the issuer. So in order to make this sort of demonstration possible, we're just going to have to simply assume that the issuer of the tokenized real estate asset is a verifiable party, such as a brokerage firm. In other words, the issuer of the tokenized assets is an agent that can be trusted. That way we can, move on with the other aspects, which is the fun stuff, which is what we can do once we're able to trust that issuer is actually issuing a legitimate token. So keep this assumption in mind whenever you're creating a tokenized asset of your own. As we say in economics, your model is only as good as your assumptions. So be completely transparent about your assumptions and especially do so to avoid any miscommunications with your community and those who trust in the authenticity of the tokenized assets that you're bringing into production. So we're counting on developers like yourself to really operate in integrity. And that way we can have more people adopting blockchain in the future. We want people to trust us without having to trust us. So overall, we assume that issuance is off-chain, a third party first and foremost. The broker issues the tokenized real estate assets, and that tokenized real estate asset is going to contain some key pieces of information. In our example, we have the list price, aka the latest price of your house that you own, along with the square footage and also the address of that house as well. So note that these variables can include whatever you want it to include. So if you want to go ahead and remix this into your own, you can add whatever other features that you want to add, and I'll get into the smart contract and show you how we do that. So what we're going to be doing as well is using a dummy API that's going to be used for demonstration purposes only. So don't bring this API into your production environment. You're going to want to actually point to an API that is pointing to real data market information, not mock data information, because once again, that would be pretty sketchy. So now's also a good time for me to point out this might be relatively fast paced for some of you. So in order to get the most out of what we're going to be doing today, I'm going to have to keep the pace pretty healthy. As such, if you're following along live, just make sure that you take notes and then just rewatch this video. Yes, that was my cat. My cat has now decided to leave finally. But if I don't let him sit on my lap while I'm doing this in the beginning, he will bite me. So I had to avoid that. So yeah, you want to go ahead and spend some time reviewing this, maybe a couple times for some of you. But the important part is that you follow along, just like listen, take notes, and make sure that you understand how the code base is intended to operate before you proceed with implementation. So if you decide to code along with us too, please avoid getting bogged down by any single issues because you can always, once again, go back and rewatch this. So also, feel free to ask any questions and we'll pop them up on the screen and I'll be able to address those in a concise manner. I'll do so and just leave those in-depth breakdowns for documentation and or just follow me on one of my socials. You can find me at 0xbuns.com. So before we continue into our practicum, let's review that architecture of the Chainlink functions. What I'm going to pull up now is I'm going to share with you the...
Are you sharing your screen or...
Oh, you read my mind. Yes, what I'm about to do right now is I'm going to share with you the user interface that I referred to earlier. And if we could pull that up on the screen. Wait for that. Okay, there we go right there. So you should be able to see on the screen very clearly that we have the UI. And what I'm going to do is I'm going to navigate us to the architecture. So here in the architecture, what we're going to see is this slideshow, which is very nice for us. So ultimately with the slideshow, we have the architecture and it's going to show you how we build our functions. So the functions architecture works as follows. With the architecture, we have the on-chain components and we also have the off-chain components. So with the on-chain components, the Chainlink functions work with having two elements, primarily the consumer contract and the billing registry contract. And this also operates off-chain by connecting into our DAWN, or decentralized Oracle network. And this will allow for us to have the ability to operate and bring in some of that off-chain information on-chain. So let's go ahead and hop into the second slide, or the third slide rather. So here we have the on-chain components. And with the on-chain components, what this allows for you to do is have the far left, you have this EOA that is requesting data from the consumer, and the consumer is sending out a request that's put through the Chainlink functions, and an Oracle event is submitted. It operates, do some things off-chain, which we'll get into in the next slide, and then it brings that back in through the Chainlink functions and through our billing registry, and then that billing registry submits that response to our consumer. And you can always optionally add in the Chainlink automation as well.
Sorry, can we zoom in a little bit? I think the font is too small.
Maybe that.
Probably a bit more. Is it possible to zoom in? Yeah, I think that's right. Cool. Thank you.
That's about as big as it can get, I think. Let's see. Now let's go to the next slide. So once again, these Chainlink functions are designed to connect your smart contract to external data providers, and it leverages our decentralized Oracle network to make this sort of bridging possible. So since smart contracts can't execute themselves, we have to use some EOA that submits this request, and that's what we just went through on the on-chain level. And on the off-chain level, we have this demonstration of what happens on the far right side. And that is whenever we're communicating through the DAWN into the API provider, and that external provider is sending out, is receiving that incoming API request, and then responding with the response that contains the data that we're looking for. So now let's look at the breakdown of these. And I think that this is really going to help really clarify what's going on the other sides. So Chainlink functions, let me see. Can you see the screen? I think I might have zoomed in too much. Is that clear on there? Okay, looks good. All right, so Chainlink functions operate on-chain via a consumer contract and a billing registry. So our consumer contract points to acts as the point of contact for the externally owned account. That's what we saw on the far left of that diagram. And they're responsible for submitting the external data request, and they receive the response and payout link for the services that they render. And in our case, we also have a billing registry with Chainlink, and the billing registry administers service payments and is activated via calls from the consumer. And it operates effectively as an escrow service that enforces payment contingencies. So let's look at some of the off-chain components as well. Okay, here we go, off-chain components. So here on the off-chain components, we have our DAWN, and we have, or rather our decentralized Oracle network, and we also have our external providers. So that was what we saw on the far right. So our DAWN receives this data request and operates as an external source for executing complex calculations that would have otherwise been costly or prohibitive on-chain. So we outsource that to our decentralized Oracle network. Our DAWN is also responsible for retrieving that requested data that it receives from the external data provider, and it brings that data back on chain. And it has its own internal verification system. Finally, we have the external data providers, aka our off-chain data sources. And what these do is they operate as a way to inform the requests that are made by the consumer contract. They're external to the blockchain itself, but they allow for you to tap into limitless different opportunities for data, because you can have multiple ways of accessing and tapping into your data from various APIs, which is very, very nice to have as well. Now let's look at the next aspect before we proceed. However, with our actually reviewing our design, we're going to, before we proceed into actually implementing it, we're going to look into our design, and that's going to show you what we do in the code base whenever we're actually implementing the architecture that we just reviewed. So our design will describe how we leverage the architecture that we just reviewed. And what we're going to do is we're going to check out how we can tokenize real estate assets by doing this. This is a little diagram that I created that attempts to highlight some of these different components. But before I dive deeper into this, we do have a very active audience today. So I'd love for you guys to try to take a guess at which of these different elements is the consumer contract elements, whether it's ERC 721, the functions, or the API, and then also which one of these three is the external provider. So maybe the position of it might help make it a little bit clear, but you're going to figure out the answer to that question here shortly. So let's look at that diagram and look at how that logical progression is made whenever you're making that request, from going from that request and then ending off at that response. So we use an ERC 721 contract that represents our real estate asset. And as Zoom has properly guessed, the ERC 721 does in fact operate as our consumer. So our NFT stores key pieces of information about our property, like we discussed earlier. That's the home address, that's the square footage, that's the price, etc. But most of those things don't need to be updated. We can assume that the address is gonna stay the same, the square footage is gonna stay the same, but the price, however, that changes over time. Hopefully that always goes up, but it doesn't all the time. And we'll see how it operates in our example. So if you said ERC 721 represents a consumer, congratulations. I see Abimbola James as well correctly guessed that. And our consumer, what does it do? It submits this request out to our Dawn, and then that Dawn receives that external information from our external data provider. So in our example, we're actually using the housing market information API that we use with our dummy data as the external data provider. So see at the top, it sends out that request for that price, which is actually a function on the smart contract, which we'll review shortly. Then it requests the latest price to that API, gets that latest price, and then updates the list price. So our external data provider is very useful and necessary in integrating this whole process. Now, let's look at how this breaks down on this last slide and how everything falls into place. So please feel free to revisit this later and just reference this on your own time. But we're going to move on to one of my favorite parts, and that's the coding part. So before we dive into the code in my VS Code, I'm going to have you take the time to go ahead and clone that GitHub repository. It will be found at github.com/smartcontractkit/RWA-tokenization. And that RWA tokenization repository can be found also here at the very bottom of the UI that I pointed you to. But before we dive into that, there's also a very neat element of this UI that allows for us to review the code here. So first and foremost, we have the imports, and you're going to use these imports in order to have the key elements of Chainlink functions. And namely, that's the functions client and the functions request. And whenever you're creating your contract, you're going to inherit those two elements and declare that your contract is in fact a functions client, so that it is able to carry out those client duties. The next element that you need to have in your smart contract, and it's going to vary from contract to contract, is your subscription ID. So Chainlink Functions requires a subscription ID in order for you to use the subscription process to make a request for a response from an external data provider or from a computation from the Dawn. So the next level that we have here is the initialization element, and that happens in the constructor. So we declare the router address as a functions client, and we have the confirmed owner as the message sender, and the Dawn ID, which varies from blockchain to blockchain. So make sure to keep that in mind whenever you're deploying it. We'll look at a deployment script whenever we get into the code, and you'll see how this is all done in this constructor. Also the gas limit, the subscription ID, and epoch, which is more specific for this use case for the purposes of preventing some spamming going on. So now, whenever you're on this UI, you can also click these buttons here, or these links here, and it'll take you over to look at some more information about what Dawn ID is, subscription ID, etc. Now let's look into the request element. So what we're doing, recall, is we are trying to update the price of your real estate asset, which means that we need to be able to submit a request. So here, starting at line 128, is where we start off that request price. And with the request price is just taking in that token ID. It's passing that token ID to the house direct that we created before, and creating an instance of that house, getting info about that house. And that info about that house includes, of course, the price. So what we'll do is we will send out that request and get put in that source pricing source info, which is the JavaScript code, which I'll get into actually right now, 'cause I think I might have skipped that. So this source price information is a very important part and is actually neatly added into the smart contract. So you know that it's in fact immutable, which is very nice because that way the whoever is using this or relying on the reliability and trustworthiness of your smart contract and the execution thereof is able to know that you can't change this data source here and the way that it's being implemented or carried out. So you have the API dot chateau voyage house, and then the ID, and the ID is that house, the token ID that's associated with the house NFT contract that you created. So NFTs are a very nice way for you to compact and compartmentalize a tokenized asset because it allows for you to have a lot more elements than a traditional fungible token would allow for you to have. So if you're not too sure why I'm saying NFT, and probably some of you very well might be thinking that NFT just means a JPEG or a PNG, whatever it might be. Well, NFTs are not just representations of visual things, but it's in fact a representation of distinct assets. So one asset having elements that are distinct from the others, but belonging to some sort of collection. In this case, we have a collection of houses that all have unique properties for each one. So unlike if you have one USDC token or one link token, another link token, and both those link tokens can be traded for one another, they're valued the same. One link token is equal to one link token. One house is not equal to another person's house. Your house is not the same as your neighbor's house most of the time. Sometimes it might be the case, but usually it's not the same house as your neighbor's house. So as such, it's a non-fungible token because each one is distinct from one another, but there's still a house at the end of the day, so all belong to this house collection. So what we'll do is we have this URI that we're going to be plugging in this key pieces of information, which is the last element. But before we get into the URI, let's look at the response. The response is where you're actually going to be, it's called by the Chainlink functions DON, and whenever it receives that response from the external data provider, from that JavaScript code that we just reviewed, it executes that off chain and gets that response. And this is how this is collected whenever it's processing the response. What it does in this case is actually using the index, it's getting that index, and then it's updating the token, it's getting the token ID as well, and then it's updating the latest price for that token ID by getting that response that we received from requesting, hey, API, what's the latest price for this house? And then it says, this is the latest price for the house. Now let's go ahead and find that token ID in our array of latest prices and go ahead and associate that token ID to a particular price. And whenever we get into this fun button over your houses, which we'll get into at the very end, and a very exciting element of this whole process, you'll see how we can look at and compare the current price and the latest price and the actual stored price in the contract. And this process response will be facilitating the update of that price that we'll see at the very end whenever we review that. Then we'll update some other elements like the list price of the house stored in that house array, as well as the last update. Now, the final element of this is the token URI. Here, what we're doing is we're setting the URI. This is just getting in that information that you input whenever you're issuing the token. So this includes the home address, the list price, as well as the square footage for that house. And then it creates this token URI, which every NFT actually incorporates on its own as well. So now let's dive into the most exciting part, in my opinion, which is the live coding components. Go ahead and pull that up for us. Alrighty. Hopefully everyone can see that. All right. So before I dive into this, I'd like to see if there's any quick questions that we can pull up on the screen. There's a lot of things on there, but if you do see anything, maybe we can highlight it on the screen and I can see if I can review it. But if not, otherwise, let's go ahead and resume. So here in the README of the repository that you may or may not have already forked on your own, you'll see that there is a getting started page here. So it's going to require that you have Git installed on your computer, that you have Foundry as well, that you have Node and the latest version of Node, ideally, which I believe is 21. Also Yarn, and you can verify that you have Yarn by running yarn dash dash v. And also you can click on any of these links to get any of these installations that you may need, as well as Dino. You're going to need all of those things in order to continue with this, as well as, of course, a MetaMask wallet and some faucet tokens. If you're not sure how to get those tokens from a faucet, well, the way that you can do so is by going back to that URL that we were at earlier, which is chateau.voyage, and then clicking on the faucets button, and that will take you to the faucets, and you can get some faucet assets from there. So let's get into the installation of these scripts. So the scripts below are going to contain some of the key pieces of information that you need in order to really go about executing a lot of the key elements of what is contained within the 3 different apps that are within this mono repository. So there's a lot of information that's contained in here. And you'll see that there is an app that's stored for contracts, one that's stored for the server, which is our backend API, aka our external data source, and also the front end. So we're going to first dive into the yarn prepare element. Whenever you run yarn prepare, you'll see in the package here, go ahead and pin this, that whenever you're preparing it, it's going to allow for you to create all the dependencies for your front end, for the server, for the contracts, and it's also going to do this neat thing called a sign-in. So that Yarn sign-in script, what that does is actually allows for you to create a password, and this password is used to actually encrypt your environment variables, and you'll be able to use this sign-in process in order to make sure that you're able to decrypt this private information whenever you need to tap into it later on. Next, after you use the yarn prepare, which I've already done on my end, you'll run yarn setup. And what yarn setup will do is it will get you set up within the contracts repository. So with yarn setup, what it'll do here is it will allow for you to do the npx env enc set, which is just setting up that private environment variables that you're going to need. And in our use case, we only need one private environment variable, and that is in all caps private underscore key. So it's going to prompt you. It's going to say, hey, what is the name of the variable you'd like to store? And then the next question will be, after you press enter, okay, go ahead and insert that information. And if you want to peek at what you have stored, you can do npx env-enc view, and that will allow for you to view that information that you inputted in there. But just make sure you don't have any nosy eyes looking around you. So next, what we're going to do is we're going to do yarn build, and what that will do is we'll carry out the make file, and there's a link here for you to see what that is composed of. It will compile your contracts and also build the front end. So it does a lot of things there at the root level for the yarn build. And then there's yarn deploy. So with yarn deploy, I already did this right before this this live stream. So what it'll do is it will allow for you to, it'll give you some information about the chain that you're deploying to. It will give you the hash after a successful deployment has been executed, as well as a contract address. So note here that whenever you have this contract address, make sure that you copy this address and that you go over here and you search and replace. If you hear snoring, it's my dog, sorry. You go over here and you go to search and you do search and replace for the existing contract address, which is stored in here. If you go to here, you'll see that this is what's stored here currently, and you'll want to update that with what you see here in your terminal. So that way you're not trying to execute the scripts on a contract that's not yours, because it won't work. Now, what you'll do after you do your deployment, actually before you do your deployment, if you haven't already, you're going to want to create a subscription. A subscription is necessary for the deployment because whenever we do the deployment, we execute this script right here. So under the apps contract script and then realestate.s.sol, you're actually able to use Solidity to push out Solidity contracts. So here we're taking advantage of one of the neat functionalities of Foundry, which is having these scripts that are written in Solidity. And in this script, what we're doing is we are go ahead and adding in here a instance of a real estate contract that we deploy, and we have those key pieces of information. This subscription ID is what brought us here, and this subscription ID is necessary for you to be able to execute that subscription. Each subscription ID is unique to a particular owner. I own the subscription 10,790. You may own another subscription ID, but you're going to need to have one that you actually own in order for you to be able to successfully carry out these updates. So what you'll need to do is yarn sub colon create, and that'll allow for you to create it. And if you also want to look at the rest of the script here, what we did here was we just added in some houses that we issued, and these are just some dummy data with just a address that we're issuing it to, along with the address of the house, the price of the house, as well as the square footage of the house. So that's really neat functionality of scripts that we're able to tap into there. And if you need any of the other documentation information for this supported network, so you can update the Dawn ID and the router address, as well as the gas limit that you're going to be referring to, make sure to check out the documentation for that. And also here, epoch is set to 2 minutes. You can set that to wherever you want it to be. Epoch just represents how often we are able to, or how frequently we're able to update this contract. So let's go right back here to what we do after we deploy. So once we deploy, what you also want to do is update the ABI everywhere where it's necessary. If you made any changes to your contract, you're going to need to do that in order for you to be able to carry out the other elements that we're going to be reviewing. And you can find that here in this, through this link, you'll find your ignored out directory within your contracts app directory. So what you'll just do is you'll open up that JSON, copy the ABI, which is contained in the brackets at the very start of that JSON. So if you have already created a subscription, then great news. What you're able to do now is you're able to then make a assignment for that particular subscription ID, assigning that subscription, assigning your consumer contract to your subscription ID. So what you'll do is you will run yarn assign, and what that does, look at the script here. What it'll do is allow for you to add your consumer contract. Does this here? Make sure you update the contract address to the subscription ID that you specify. So let's go ahead and run that here in the terminal. I have not yet done that. So do yarn assign, and it shows you the hard hat functionality that's being executed here. And it's showing you that it's adding the contract that we specified to the subscription that I created. And after that is added or assigned, what we're going to want to do is make sure it has this confirmation notice here. Great news. And then what we're able to do is make sure that, again, that subscription ID is properly updated and that it belongs to the private key that you own. And now what we can move on to is yarn serve. So let me see if there's any questions from anyone. Also, is the size good too on the screen? The link for the OCR is running 404 error. Okay, thank you for helping out with that. Okay. Can you guys hear me well? Maybe you gotta speak a little bit louder. Okay, I'll speak up a little bit. All right, so what we're gonna do now is we're gonna go on to yarn serve. And here, what it shows is what that will do is will put us into our server app, and then it will allow for us to go ahead and get it started. So I'm going to do that here separately. So I have these multiple terminals here. So we're going to do is yarn start. And you'll see that the API will be running. And it'll be running in this case in localhost 3002. So I'm going to share that with you so you can see what that looks like. Alrighty. See if that's showing. Okay, you should see a black screen. Okay, so it should just say okay. And what we're going to do is we're going to see that there is some neat elements that we have packaged into the server. And you can find it here in houses. If you're looking at the repository, you'll be able to see that it has a server app, and then in API is where it will be the code that informs what you're about to see here on the screen. So you can see the total amount of houses, and we just use houses. And if you want to specify a particular house, we can use the index of that house, and you'll see what that information looks like. So here what we have is the ID, we have the list price, the latest price, square footage, the time it was created, the latest update, the epoch, which is 120, which is basically 2 minutes, or it is exactly 2 minutes, and the amount of epochs that have elapsed since then. And then what we're going to do now is we're going to go back to the code. Just wanted to make sure that y'all saw what that looks like. Alrighty, thank you so much. So now we have the code again, and now that you have this API running successfully, hopefully that gives you a little bit of an idea of what that infrastructure looks like on that far right end where it shows the external data provider. And in this case, you'll be your own data provider. In production environments, you likely won't be your own data provider. You'll be using something like a Zillow API or something of that nature to help you with facilitating and carrying out the actual price of a particular house. So it's really neat functionality. And now what we'll do is we will go ahead and move forward with looking at the user interface. So let's go to the front ends. And what we'll do is we can do, if you're on the root page, you can just do the yarn, what is it? Yarn show. And yarn show will allow for you to do what I'm about to show you right now. So we're going to just do yarn dev. And I'll share what that looks like with you on the screen. So there we go. On the screen now we have the live version of the website, chateau.voyage, but this time it's actually running here, and we're able to manipulate some of the information that's on the screen here. And what I'm going to point you to here is the houses. So if you click on houses, currently not working that way. So if you do a token ID, let's do search data, token ID. Ah, look at that. We have the current price and we have the stored price. And the current price for this house is actually on the market right now at 1.2 million and 540. So 1.1,200,540. However, on chain, we have it stored as 1.2 million on the dot, which means that we have a mismatch. So what we'll do is we'll use this update contract button, and it will allow for us to actually update the information that's stored on chain, ideally. So I clicked it, and let's see what happens. If you're using this terminal, if you're also able to look at your own terminal, you'll see that it will show you the information about that transaction whenever you submit it. So it looks like that transaction was submitted. Let's go ahead and refresh it, refresh the page here. There we go. And it takes a second for the API and the UI to all configure in line with one another. But you see now that it's in green, which means that we were able to successfully execute the request price. And if you recall, we have the contract right here. And what we have here is the request price function, which is just inserting in this token ID that we specified. And then it allows for us to get the price for the token that we specified. But what you'll notice is if you go to another token ID, for example, this one here, we have 225,550, but the store price is different. That one won't be updated unless you specify that you want that token ID to be updated. So you follow that same sort of process where you would click on update contract, it'll execute that contract. And while it's doing that, I'm going to go ahead and change up the page back into our code. And here it goes. Sorry, my cat's never been like this. It's very, very loud today. And here in our code, you will see what happens whenever we press that button. So we have here the information that just confirms that this was actually successfully executed, gives you that key piece of information, and including the request ID as well. And let's dive into what that looks like on the front end in the code base here. So in the code base for the front end, what happens is we have an app, and in the app, we have the tokenization elements that allows for you to get in the token input, add in that information, get that off-chain data and compare it. And it's using this off-chain response component in order for you to do so. There's a lot going on here, so I'm not going to actually have time to go through every element of this. But if you are looking at the code and you have any questions about the code, feel free to ask that in the chat and I will do my best to help you out with that. Okay, so I see someone's asking if I can zoom in for them. Okay, that's about as much as I can zoom in, unfortunately, without it getting a little too overwhelming. But let me try. Yeah, it's a little bit too much of a zoom there, unfortunately. So let me see. What we can get into now is the contract, which is a great part of this process. In the contracts repository, we have some neat tasks that we're able to carry out. And that's where we're going to spend the remainder of our time today, is here in our tasks. So you'll go to, if you're looking at the repository, you'll go to apps, contracts, and then you'll go over to tasks. And in the tasks, you're able to execute things with our biller and also with our consumer. So these are the contracts. Remember, we have the on-chain components that we discussed before, and that being the billing registry and the consumer, right? So your consumer address, you can do different things with it, such as request and get responses. So what we're going to do is we're going to navigate into our terminal with contracts. And what we'll do is we'll go ahead and review what those scripts are. Maybe that helps a little bit. So review what those scripts are. We have sign in, sign up, build, done these things. Now let's look at the price, for example. So we do yarn price. And this will tell us the list price, and that will tell us the list price for the first token that we have in that list. And as you probably might have remembered, it is $1,200,550, and that list price is put out right here. And you're able to review that and how that's actually going through whenever you go to your scripts and then get price, and it's just requesting from the contract itself what is the response that is received whenever we try to get the price and it uses the price config in order to inform that process. So the price configuration is something that you need, and a configuration in general is something that you need whenever you're setting up your functions. And whenever you're setting it up on your machine, you're going to need to have certain elements of that request configuration in order to carry out this in your locally on your machine. So you're going to need to have the code location, the code language, and currently we only support JavaScript, the source for the code that you're going to be executing. In our case, we have the price request here. And this JavaScript, which we'll get into right after this configuration. If you have any secret keys, you'll store it in secrets. Args is just the arguments that you'll be passing into the code that you execute here with price request that we'll look into here in a second. The expected return type, in this case, we have a uint, which is just a number that is unsigned integer, and some other key pieces of information. Let's hop into the JavaScript code. So it's a very, very basic. It can get really complex, but here we're just going to keep it very simple. We have the token ID, which is the first argument that's passed in through that arguments array. And you can see you just declare args and it actually is able to understand that it's getting it from the configuration. It's then also using the API response. It's making use of the make HTTP request from functions. You just declare functions and then do dot in order to access that functionality of make HTTP request. Use the URL that aligns with the API that you're trying to request from, and insert any of that, any of the arguments that you need to insert. In our case, we just have a token ID that we're passing in. As we saw earlier, whenever we were looking at the server component, we had the token ID of 0, token ID of 1, 2, 3, etc. And it was giving us that output of what that looks like whenever we submit that request. It has that JSON that contains different key pieces of information. But in our case, we don't really care too much about the house address being updated or the square footage being updated. We do, however, care about the list price being updated. So the API response is the get API response.data to grab onto that data. That'll give you all the data, but we want to specify what data that we're looking for. And in our case, we're looking for the list price. And we see here this console log of the list price. And then finally, we're just returning that list price so that we're able to complete this execution of this JavaScript. Now let's look at the very neat aspects that we can also do here. We use the subcreate, and that's using Hardhat to execute the subcreate here, which is that billing, and then here it's the create JavaScript. And also similarly for assigning or adding a consumer contract into a specified subscription ID. And again, that's these arguments that you're passing in here. Contract is an argument, as is the sub ID. And if you're creating a subscription, you'll see also here the amount that you're passing in, and that is for the amount of link that you're going to be adding into a subscription that you create for the first time. Now let's look at the last two elements, and those being the request and the response flow. So with the request and the response flow, let's go ahead and carry out the execution of both of those. So let's start off by doing the request. So we're going to go ahead and do yarn request. But before we do that, I'm going to show you what's happening under the hood here. So with the yarn request, what we're going to have is some of these parameters, and these are the required parameters. That's the contract address, because you can't request something from nothing. The sub ID, because you need something to help with carrying out the billing of that particular request. The token ID, which is the index of the token that you're requesting to update the price for. And then you can have some other optional parameters like the callback limit, etc. So those are things that you can look into the documentation for. If you have a question about it, you can also ask that in chat. Okay, thank you, Jether. That makes sense. And now what's doing, it's setting the actions. The action is what we're actually going to be carrying out. It's async, so it means it's going to be able to tap into this await functionality, which means that we can do things like await for the contract factory to actually deploy the contract, which is, in our case, named real estate. So if you don't have real estate, if an error pops up saying that like you don't have the artifacts for the contract that you're trying to get with ethers.get contract factory, what you're going to need to do is you're going to need to run yarn build within the contracts app in order for you to create that that information that you're going to need in order to resume. So then also you have the consumer contract, which is just using this consumer factory, and it's attaching to that factory this address that we just deployed, and that we declared rather here in our task argument for consumer contract, or just dash contract. Then what it'll do is it will go ahead and perform the simulation, and then it will get in the do some other manipulations that I won't get into just for the purpose of time here. The most interesting aspect of this happens right around here, where it's actually looking at the request here. So you see request transaction, which is where all the magic happens. It's getting the consumer contract, and there is one function that we're calling, and that is the request price functionality that just takes in the token ID and the index of that token, which is effectively the same. And it will just submit that request like we saw earlier whenever we were looking at the front end, and we saw that it's doing a request price and how that operates internally whenever it's reaching out. So let's go ahead and do that yarn request here in our terminal, and you can see what's carrying out there. Okay, so if you get an error like this, what you'll do is, I already know that I've already added in that environment variable, so the error message could be a little bit better. What you're gonna wanna do is you're gonna wanna do yarn sign in. Wait, did I spell that right? Yarn, yeah, I didn't spell it right. Yarn sign in, alrighty. And then you're gonna type in that password that you had created originally, and that will allow for you to tap into those encrypted environment variables. So now we're just going to try this again, yarn request. So like I said before, it's going to perform that local simulation. It's also now going to prompt you for whether or not you're okay with the charge that is going to be charged here. Why not? Let's go ahead and spin some of that link. That's what it's used for as utility. And transaction confirmed. So you'll see here, there will be a actual URL pointing to the transaction confirmation. And in this case, it is showing us the confirmation for the transaction that we submitted. So I won't show that on screen, but what we'll know is that on the transaction submission, what it'll do is it will provide you, if you go to the logs, it will allow for you to look at the subscription ID, the subscription owner and initiator of that request, data, the client that it's communicating with. It gives you some really interesting pieces of information. One thing that I really like as well is the request ID. The request ID is something that you can input back into one of the functions for the consumer contract, so that you can see whenever this given request ID was passed in, what was the last response, right? So that's a really neat aspect of tapping into that request ID. So let me close that. All right, so now here back into contracts, let's do the final script that we're going to be running today. That's the response. So this is just grabbing in the parameters that we specify. That's the contract and the token ID. Those only two parameters that we need in this case. And what we'll do is we'll read the latest response or error, if there's an error, that was returned from the functions consumer by the token ID that we pass into that script. So we dive into what that script looks like before we run it, because we do want to know what we're doing before we do it. There is here, it's using hard hat to execute func response. And if you're wondering what is func response, what is func request, why is it so funky? So you're going to go over here to your tasks, and you'll see here that they're named in the very beginning. So in this case, it's func response is what I named it. So if you're looking for where that's coming from, that's where it's coming from. You're going to need to pass in the network. In our case, we're using Avalanche Fuji, the contract, as well as the token ID. We don't need a sub ID this time because we're just reading from the contract effectively. So what we'll do is yarn response here. See, it's being carried out. Reading data. Boom. Now it's a formatted response that we're getting on chain, and that's showing you us here. It is $1,200,550.00. That is the latest response that is on chain. So that concludes what we reviewed today. We got into a lot of things and covered a lot of ground. So you may have a lot of questions in your mind about what is going on. And if you need any help or assistance, I strongly refer you back into that UI that we created, that we looked at the very beginning, where it's breaking down and showing you the slides for how this is carried out from the architecture component. Make sure that you really understand how this is laid out, how it is created in the abstract, and then move on to, after you fully understand that, move on to the actual design, which is our implementation of that architecture, which is just saying, like, how are we in this case actually carrying out what functions are able to do, so that we're able to tokenize real estate, have and tap into all of the great details that you're able to tap into, that rich data value that you get whenever you have a tokenized asset, and whenever you're tapping into Chainlink's functionality to leverage that external data provider to provide information to on-chain contracts, something that's not able to be done absent having some way of solving that problem, because blockchains exist in a silo. They don't know anything unless it's told something, or unless it's transacted explicitly on that blockchain, because it's just a public ledger. It's telling you what's going on the blockchain, not what's going on in the real world, right? So you need to be able to have a way to bridge that gap, and that's where Chainlink comes into play. And then once you're fully familiar with the design from the conceptual level of that design, you can then look at how that design is implemented within the contract itself. You can use those toggles to toggle over different tabs that align with different elements of the contract. And then what you'll want to do is then open up the repository, get familiar with this root README, and whenever you're doing that, you'll see here too in the directory, each of these directories also have a corresponding README, and that will take you into, for example, here in the contracts README, I specify in full detail within that contracts the contracts app, all the things that you'll need to do in order to carry out the functions workflow. That includes making it, building it, setting up your environment variables, storing environment variables, simulating the functions, deploying your consumer, creating a subscription, making those requests, and making those queries. And bonus points if you can think of ways to get these tasks and make more tasks of your own. So things like just requests. You're just transacting on a thing. So you just would go in here, you would really just change if there's any parameters that you would need for whatever specific thing that you're trying to carry out. Just do add param, remove any parameters that you don't need, and then you'll get those parameters. They're stored as task args here, and just make sure that you keep it all lowercase too, by the way. Just manipulate those parameters into a usable constant, just using like parse int if it's a number, for example, and then get that information that you may need to pass into a function that you're going to be executing. So you'll, in this case, we'll scroll down to where we're executing a functionality. That's the request price functionality. And that's it. Boom. Now you have a task that you just custom made on your own. You should be able to do that within a very short amount of time, provided that you're familiar with the contract that you just deployed. So this is just something that you can take home with you. You can mix it up, make it work for your particular use case, and hopefully this README will provide you with sufficient information for you to be able to carry out all those neat functionalities that we discussed. And finally, what you'll do is make sure that you take note of all the information that is contained on the README, which you truly understand it before you move on with actually deploying it. And once again, if you have any questions, please feel free to reach out. You can find me at zeroexponents.com. You can also go to our docs, docs.chain.link. There we have amazing team working on documentation that's constantly updated to all of the new updates that we need to make to our documentation as we bring out and roll out new products. And it's a very exciting time to be here in blockchain, and also for us to be involved with Chainlink, because Chainlink is just bringing out a lot of amazing products. We just started off with the data feeds at the very beginning, and now we can do so much more with automations, functions, VRF, etc. So the world is your oyster, and just make sure you're acting responsibly whenever you're doing these things too. You only have, you're only as good as your word, and only as good as your name. So make sure that you are putting forth your best effort, and just being honest with your community and with yourself as well. So don't be afraid to ask for help. Nothing wrong with asking for help. And I hope that you learned something today. Thank you so much. And I hope that y'all have a good one. I don't know if we're going to wrap it up or if I'm wrapping up things. I'm really bad at wrapping up things. So bye.